Okay, great. So welcome all, and thank you for coming to this session. This session is about introducing model risk, how model risk works, and also how is it that you're going to migrate if you have at risk. How is that you're migrate from at risk to model risk, right? That's the main idea of today's session, right? So ModelRisk is built by Vose Software. Vose Software is a company based out of Belgium. Vose Software has been for more than 20 years around, right? It's been for a lot of time that Vose Software is there. At the beginning, they were a consultant at the beginning, and then they generated its own software, which is ModelRisk. It involves developers for risk analysis and risk management. And how is it that Fairfield matches with Vose Software? We are the commercial arm of Vose Software at the moment, right? That means that we are in charge of all the promotion and sales for the software of Vose Software, right? The main products that they have, and this is the one that we're going to talk about today, is ModelRisk, which is Monte Carlo simulation on top of Excel, right? Which has more than 18 years on the market. And also they have something, a software is called Tamara, which does Monte Carlo simulation for Primavera risk analysis and also for MS Project, and also Pelican, which is an enterprise risk management software, right? We're going to focus our efforts today in ModelRisk, right? A couple of clients were not a couple, maybe almost 100, but you will see that you have people in the insurance space, in the development space, in the energy space, in the retailer space, in the defense, energy again, food, etc., pharmaceuticals, etc. So I've been lucky enough to know some of these people, and they are very, very happy with ModelRisk. So I'm going to show you what it does. So what does ModelRisk do? It's a risk quantification, right? It's basically adding Monte Carlo simulation on top of a model in Excel. Besides all the risk quantification that I'm going to show in a second, right? You have dozens of distributions to choose from. You have more than 130 distributions. The users, they can easily choose between one of them, and they can easily include uncertainty and risk events. We're going to see that in the moment that in the model that I have. We can model scenarios. So, for example, you can have a deterministic, optimistic or pessimistic scenario. We can add correlations and copulas, and we have complete reporting capabilities. So we're going to see some of this. We're going to see distribution fitting. This is something that I prepare as well, as I imagine that you will be interested in taking a look to that, right? Is model risk simulation only? No, we have portfolio optimization using the CAPM model. We have integration with the ERM to Pelican, the ones that I just mentioned before. We have time series modeling as well, and we have data and a results viewer, right? And simulation import data management. It's called SITS, right? And we have some key drivers reporting as well. So you see, the tool itself, it's an umbrella for many different options, and we're going to see some of them today. If you have the time, of course, we have our website. I'm going to show you our website that where you have our video library, and you can go here. Let me show you here let me add it into our. You go. So if you go here, if you go to Vose Software, you have our QRA trainings. We had one yesterday, and here we have our Vose Software dedicated section. So we have selecting the right distribution, moving from at risk to model risk. We have time series. We have Pelican that I mentioned before. We have correlations, sim tables, etc. So if you want, of course, we have all this information. This is free. You can just go there to the address that I sent you. Maybe you will have to register if you were not registered before with your Google or Facebook account, the typical registration, next, and then you're going to see that. And then you can take a look to these videos, and we are very keen on sharing what we know and sharing it to the world so we improve the practice, right? So this is what we wanted to talk about. Now, let me share a model that I have prepared that is going to showcase a few things that we have from ModelRisk, right? ModelRisk, as you see here, I have ModelRisk here. ModelRisk is an add-in to Excel like this, right? And you see that if you take a look, the interface is very like the one that you have in at-risk. Why? Because I decided to start, you see, what you can do, you can customize the ribbon, and I chose the at-risk style. That means that the order of the buttons that I have here is going to be the exact same one that you have in at-risk. That's really good. If you're thinking about changing it from at-risk to ModelRisk, it's really good because it helps people understand and not having a learning curve of where to point and click, right? Now, the model that I prepare is a model that has a baseline cost estimation, right? This cost estimation has 70 items, right? And each one of the items has its particular phase. You see the design, engineering, implementation, testing, refinement, etc. Each one of them has at the beginning, most likely value or the value that the subject matter expert calculated, which makes it up to 9.3 million, right? If we know, for example, let's say that we have a 3% contingency, that's going to be 281, right? It's going to be more or less 9.6 million. That's the total, right? And that the idea here is that we're going to be able to add uncertainty to it, right? And to add a risk register on top of that. So how is it that we're going to add uncertainty? We're going to include, to the most likely, remember the deterministic, we're going to include an uncertainty range for each one of them. You see, for example, for the design requirements, we had a most likely of 50, but we have a minimum of 45 and a maximum of 100, right? So what we do, we generate this as a PERT distribution, you see here, with this Vose PERT command. That's going to say that minimum is going to be F6, most likely E6, and the G6 is going to be the maximum, like that. If you like, you can take a look here in the distribution, I'm sorry, in the view function, you can take a look to the distribution like this. You see, 45, 50, right, and 100. So it's more or less what we have there, right, for each one of them. Now, you will see that each one of the cells has this Vose input, which is a declaration. It's saying basically, this is the name of each one of the cells. So the name is going to be C6. C6 is a hidden cell. Let me show you here. C6 is the combination of the phase and the item, right? I just did it like this. So it is simpler for us to understand what is it that you have there, right? You don't need this one here. Here you go, okay? For each one of them. Now, we accepted, right, initially that the PERT distribution could be the same for each and every one of them. That is fine. You see, we have this 70 distributions, meaning that if I press F9, all the 70 are going to change, right? And if we see the total, remember that the total, you see how it's going to oscillate, 9.1, 9.5, 11, 10, etc. Because for some of them, I added on purpose a very high volatility, like for example here, right? You have 150 to 500 to 2,000, 40 and 30, 350 and 1,500, like that. So you see that you can set up all these extreme distributions. Imagine this one here. You see, you have a big tail here from 200 to 1,500, right? So this is the type of distribution that you can set up for each one of them. Now, what you could do, instead of saying this is a PERT distribution, let's say that we have data for that. Imagine that for the load and performance simulation, we have some historical data here for the load and performance. So what you can do, you can take all this information. We have, in this case, 300 simulated fictitious data points. And what you can do fit, distribution fitting. And instead of going with the PERT distribution, which could be one of the options, you can say add. And of course, you will be able to say, well, I want this to be a PERT distribution, right? If you like. But if not, what I can do is I can take all of this and say, well, I want to test each one of them against it, and see which one is the best one. So I click in OK. This is going to fit the distribution. It's going to give me the best option. Take a look here. So the best option is this Kumaraj Maui. This is one of the distributions that could be the one. Another one is the log triangle that I really like. I started to love it when I first started with Vose, right? The other is this Weibull distribution, which is much more, I would say, known in any community. So sometimes it's better, instead of using a distribution that like the GPD distribution here that might be a best fit, sometimes it's better just to stay with the ones that you know. Right? That's a good thing to know. And the Weibull distribution here. So I can just insert to the worksheet, and it will say you want to insert a link to the data or not link. If it's linked to the data and you have a feed that, for example, of prices or productivity, sensors, etc., that it's continuously feeding or maybe daily feeding, that means that you don't need to generate this every day, because you know the type of distribution that you would like and you just go for it. But in this case, what I will do is not link to data. That means it's going to be a static answer. So I go here and I say, I want my cell there, right? I close it, and this is the distribution. It's a Weibull distribution that I got here. So for the load and transformation, this is the distribution that I will use, right? Instead of the PERT distribution, I can come here and take a look and say, well, I'm not going to use that. I'm going to use the Weibull distribution like that. So that means that you can use any type of distribution and combine the distribution, because during the sampling process, you can combine any type of distribution like this, you see? Oops. Like this. Right? And I can do the same, for example, with the design review meetings. Imagine that you have information for that. That means that you will be able to do the same, right? I'm not going to do exactly the same thing, but this you can do a distribution fitting as well, right? Now that we have that, there's another thing that we can add, right? Because what we could do, imagine, we could add a risk register, which is here. So risk register, what's going to add is going to add risk register's T column. So let me explain what the risk register is. So the risk register is going to be an inventory of all the risks that you have, right? This inventory of risks is going to have, in this case, 5 risks. You can have the ones as many as you need, right? And they could be multiple or single. If they are single, you will go with the probability of happening, right? And you will use a Bernoulli distribution. And if they are multiple, you will go with a Poisson distribution, right? Here, you go with a Poisson distribution. Here you go with a Bernoulli distribution. Why you go with a Bernoulli? Because they can happen once or not, right? It's 0 or 1. It's a binary output for the Bernoulli distribution. With the Poisson distribution, is different. You can have many. For example, here with the Vose Poisson, you can come here and you see what's going to be the distribution for it. Right? In a different case, here with a Bernoulli distribution, the moment that you see it, right, it's just 0 or 1, right? That's the difference, the main difference that you have. And also you have the impact. The impact is going to be a PERT distribution. So what you can basically do, let me show you here, right? You're basically predicting the future, right? In column E, you see how the numbers change. The same thing in column I. So they are multiplied with each other. This is not exactly multiplied. This is a functionality called Vose aggregate MC, which basically is if you have, for example, 3 events of resource scarcity, it's going to generate automatically and internally 3 samples and sum them together instead of just simply multiplying the one that you have, right? So this is something that you have upfront with the software. You have a mitigation action, And finally, you have a residual risk or the post-mitigation or the target risk, which is this. So I'm basically adding the target risk to my model here. But I'm going to do one thing, right? I'm going to do this. I'm going to take this risk register I have here. I'm going to take this out, and I'm going to do a summation here because I want to have a partial product, right? So you understand the effect, right? So I have this 9,000, right, which is the summation of my total cost plus the details, plus the risk register. So I'm going to do two totals, one without the risk, total cost, and here this is going to be called total cost plus risk, like this. You see, so we are adding that. So what I want to do, I want to isolate in this case, the effect of the risks, right? So I'm going to save that. You save it as a normal Excel file, right? And what you do, you can go to the model risk, run the model. You see that you have a number of iterations here. I will set up, for example, that I don't want the show results at the end, right? So I can run it. Right? And what I will do, take a look here. What I will do, I will take a look, first of all, here in the Explore button. Right? And what this is going to give me, and I will show you here in a minute, is the total cost. You see, is the total cost. You can see it as a histogram, or you can see it as a cumulative chart, like this. But on top of that, remember that you have the total cost plus risk. So this is the one that I added here, you see? And you see that it's not a big change, the one that you have. Okay? And this is what I wanted to show you, right? Of course, you can always take a look to this and see what is in this case, the difference between the two. For example, let's say that we want to see the difference in P80, because you see that we have this 0 there that it's not very helpful. So what I would say, let's take the P80 and see what happens. You see that P80 from the red one is 10,751 and the other is 10,875. So it's not a big change because of the risks. So now we know, you see, we analyze first in this case, we were able to analyze very quickly the effect of the risks on top of the model. Now, what else do we have? We have the ability, right, to report this. Remember that I said you have excellent reporting capabilities. So what you can do, and I did, for example, I calculated P80, I calculated the mean, and I calculated the contingency. But I only did it for the first one. So what I can do is I can replicate this to the second one, like this, right? Let me get rid of the border so it doesn't look bad, like this, right? And what I will do, you see, you don't have simulation results yet. You just have to run the model, and you will see what's the difference, right? Like that. And I think that this is going to be multiplied by this. Right? So in the first one, yeah, you see that the difference is very, very small. In the first one, you had 3% upfront contingency. Now that we added the uncertainty, you have 6%, and then you have practically the same amount because the risks are very, very small. If I have risks that are very high, this is going to be included, and this is going to be very, very high. So for example, what if you have risks that are like this, 1,200, 1,300, 500? Let's just work with that just for you to know the space. So we run the simulation, and you will see the difference. Maybe it's going to be a small difference, like this, you see? Now you have a higher difference there. So that means that this is how the model risk will work, right? You will have to change the parameters of the distributions, whether it is in the risk register or in the cost detail here. Remember that we can change all of this together, and then we can generate a proper solution. Now, what else can we do? And this is why I did it on purpose, because I know that we have 70 cost items here. So of course, if we want, and I did it, right, I can do insert tornado chart, But if we do a tornado chart of the total cost, take a look to what's happening, right? It's going to be a lot of things going on together here. So let me work on that so you can see how easy it is to make this nicer, right? First of all, we're going to include all of the cost detail, the 70, right? But we are not going to include the risk register yet, right? So what you can do, you can say, okay, so for the tornado options, first of all, I want to see which ones are the ones that are responsible for my risk. So for that, you will come here and we'll say, well, let's do a proportion of the risk. So that's much better, right? But now I have to include all the ones in the cost detail and eliminate the risks like this, right? So you have 20% for the implementation, 16% for testing, SCADA, implementation, testing, etc. I can say I want only the first 10 tasks like this. And now it's much better. You see, you have only the 10 tasks. You can change the title if you like. You see, it's going to be contribution to risk for costs, right? You can change that, right? It is simpler. And then if you go to home and copy the selected chart, you can copy that in Excel. If you like, what you can do, right, you can go to the graphics portion that I selected here. It left it blank on purpose. And what I can do is I can stamp it as a link chart like this. So if I stamp it as a link chart like that, every time that I run the model, this chart is going to be updated on the fly. So you don't have to do anything, and this is going to be updated on the fly. Now, what else you can do? You see that the usage of ModelRisk, it's the same usage that you will have in AdRisk, the same usage that you will have in Crystal Ball is exactly the same. I would say, because I've been using this for more than 2 years now, that it's much better. The graphical capabilities are much better. Selecting the distribution is better, and you don't have this special copy and paste that you have that I recall in Crystal Ball. Now, if I want to do it, what I can do is I can say, now I want to see this tornado, but for the one including the risks. And let's see if we have risks there that are that are very high. For example, here, I include all my risks like this, and you will see that you will have here the impact approval we have all these risks here, you see. Let's see, these are, and the rest are all cost items. So the exchange rate exposure perhaps is one of the risks that I should be taking into consideration. Maybe the problems with community, but of course, we'll have to manage and set up the model correctly in a way that these reflect the real, in this case, the project capability. Now, what else we can do with this? Right? What we can do is we can insert a box plot and say, well, I want to see, for example, the main, I don't know, implementation, pipe, cutting, testing, scale, etc. So what you have here is implementation. You see, you have all of them. And these are inputs. I'm going to combine inputs with outputs. So for example, I can say, I want to see the total cost and the total cost plus risk. That's perfect. I see the two. But remember that the biggest one was the implementation. And let me see what the name was, pipe cutting. So implementation pipe cutting, which is here. So I can add that here, and I can do all the implementation if I like this. If you see that they are very small, I can say, well, I just want to focus on that. Right? And then I can do the SCADA testing or something like that, right? And remember that we have the SCADA testing like this. So you see that you can have as many as you want. It could be inputs and outputs, right? You can change that instead to a whiskers plot to a graphic like this, which is a distribution, which is really nice, right? So you have that as well. And then you can always change that. You see the bottom 1, 5, 25, etc. You can show the legends if you like, so it's very easy to understand, right? And also you have the ability to change the information here, right? So you have a complete navigator of that, right? Just in case, if you want to have. This is a complete platform for you to navigate through the results. So this is really, really, really nice, right? What else you have here in the graphics? You can set up the data list, which is basically taking a look to the 1,000 iterations that I have for any variable. So you see that instead of having to browse through each one of them, I can say, well, I just want to have the total cost, for example, or the total cost on risk. So you will have all of this here. And of course, you can say, I don't want my risks, or maybe you prefer the risks and you're going to do an analysis of the risks. So you see here that some of them are going to have zeros because they happen, and the others, they don't happen, like that. So you have all the potential analysis here that you want to do. So you see that you can drill down inside the model with a lot of views, And that's what makes this really, really powerful. Now, what else you could do? And I'm going to move to what you can do when you're going to migrate from at-risk. What you have is you have a converter, and you will remember that that I show you that we have a complete 1 hour video about doing that. So if you have a model from Crystal Ball and the model is open here, you can just click there, and this is going to change it automatically. The same thing from at-risk, right? If you have a model from at-risk open, you just have to click in OK, and this is going to change it. If you have a bulk at-risk folder, let's say that you have 20 models, so you can prepare a folder with all the at-risk model. This is going to take all these models and convert all the 20. So this is very, very helpful as well. Right? So I really like this capability that you have there to convert in bulk. Right? What else you can do? You can change the language automatically here. So you don't have to download a special package with the language. You just can enter the language that you like, and the menu and all the application is going to change automatically. Right? Now, in terms of models, I really like what they did lately, which is adding these examples here. And what these examples open, and let me send you the address here. Right. What they did is that you have all these models for Excel, right? And for each one of them, for example, oil in place and reserve estimation. So you can view it. You see the level of difficulty. It's a very simple one. So you can view it. You can download the model for free, right? And they explain it, and they explain it really well, right? How each one of the models is built, right? And the formulas that you have below, and how is it that you're going to see it, right? Like this. And how is it that you're going to see all of these different graphics and all that? So it's really neat the way in which you can learn from the models. You have more, I would say more than 50 models that you have easily there. And of course, if you want us to share with you a couple of models, simple models about cost estimation and all that, that's going to be very, very, we're going to do it gladly. So now, additional things that you can do. You see that we've seen the cost detail, the risk register, right? The distribution fitting, how to add graphics. And now I'm going to show you the consolidated report. Why is that? Because what I can do is I can do a simple sum if here, right? That's going to change every time that the model changes, right? So you have, for example, design is going to be 1.25 million. So that means that if I sum all of the design, you see, if I do this summation, I have this 1.5257. Why is it that I'm showing you that? Because that means that you can set up totals at any level of your hierarchy. In this case, if it's a cost estimation model and you have 5 hierarchies, as long as you have some way of identifying the hierarchy, you can set up different partial totals. In this case, the partial total is going to be the one that I have here for the design. And what I did for each one of them, I did a sum if, right, for each one of them. So that means that for each one of these totals, I have the total at the end, right? This one here, for the risk register, I will have to take this, because I changed, remember they changed it, so I'll have to add it in here, right? It's going to be the risk register. Right? So in that case, now everything is moving like that. And what I did, I added some reporting, and the reporting was used using the Vose sim mean and the Vose sim percentile. And I'm going to add the maximum as well here. I wanted to do it with you. So I will do the maximum here. And I will say, I want to see the Vose sim max of this distribution. This now is the input, and I can convert it as an input, and you will see what happens, right? So I can do it like that, right? And of course, I can take Vose sim max. Vose equal Vose sim max from the simulated result, right? Now, let me run the simulation and I'll explain a couple of things. Right, a couple of things here. Let me see. First of all, you see that I have the mean of each one of them. You see, I have the mean of each one of them. And what I can do, you can do the summation of this or the mean of the total, right? And it's going to have the same value, right? Because the mean of the sums is the sum of the means, right? So that's the only one that you can sum. Then I also got P80s. You see, I use the Vose sim percentile functionality, which is here, right? And that means that if you have the distribution for the output, you can take the P80, and I did it for each and every one of them. Right? So that's the second way in which you can do that. That's the second way. Of course, you can never do the summation. You see that you have the summation of this, which is 11,000. You cannot sum P80s. So that's why I have the P80 of the total here. Same thing with the maximums. You cannot sum the maximums, but you just have to take the sum, the maximum of the total, right? So that's what I did here, right? So in terms of capabilities, of what you can do, and this is what I wanted to show you, you have the exact same capabilities that you had both in Cristobal and then you had in at-risk, but of course, in a much more sensitive way, in a much simpler way, right? So you have the Vose sim max here. So you can add it like that, right? So what we wanted to show today, and I'm going to give you some space, Jameson, just for you to talk about pricing. We wanted to give you some space for you to learn how is it that you can add uncertainty on top of a simple, not that simple, on top of a cost estimation model, which has 70 items, and of course you can have 700 items. But at the same time, add risk register capabilities, add distribution fitting, which is something that you will have if you have access to historical information, and also build a consolidated report. So for this consolidated report, you see that you can see the same view as if you will be seeing that after doing a lot of processing. What I wanted to show you is that you can easily generate these additional inputs, right? If you like, right? So for example, here, I can make this an output and I can generate this as an output, and we can have tornadoes for example, in a different level of granularity. Remember that the tornadoes that we had before, right? Like this, let me show you here. The tornadoes were very, very at the task level, right? If I want these tornadoes to be in a different level, right, what I can do is I can set this as a Vose output like this. Let's see, cost consolidated, right? Consolidated, like that. And for each one of the simulated results, right, I will select them. I will select them as inputs and say, well, this is each one of them, like that. Right? Now they are inputs, all of this. And we have our cost consolidated. So what I will do, I will run a simulation. And what this is going to do is going to set up a tornado chart. Let me see here. Let me show you. How it's coming. Let me see if I can make this work. I'm not sure why is it that it's not working. Well, what I wanted to show you is that what you can do is you can set up a tornado at this level, right? Instead of just having the tornado at the same level that you have, which was a tornado at the task level, you can set up this simulation results, right? In this case, at the design, engineering, risk register level, etc., but without having to copy to another model by just doing these sum ifs here. I think it's because I set it up like that. I think that we'll have some issue with this. So maybe, Jameson, you want to talk about a little bit of the pricing?
Certainly. Happy to.
You
I have a little pricing matrix here I could share.
Oh, please do. Please share. Please share. Here you go.
Let's see if you guys can see that. Do you see that?
Not yet. Should I give you permissions? No, I don't think so.
Maybe. Let's see.
No, no, it's coming.
There
we
go. Good, good.
Yeah.
Great. So, because Vose is a Belgian company, they sell in euros, but with Fairfield you can purchase ModelRisk in US dollars now through Fairfield, and I have the pricing here. So the ModelRisk desktop is 1,580, and I believe the at-risk professional right now may be $2,500. ModelRisk is a little more similar to the at-risk industrial, if you're familiar with that. I'm not sure what the pricing is on Crystal Ball anymore, so I haven't looked, but it's over multiple licenses. There's multiple license discounts that are quite a bit different than the competitors. That's much better. So we're certainly willing to work with anything their folks need to move over to ModelRisk.
Excellent.
And the concurrent network is considerably cheaper also than the Lumivero product.
Thank you, Jameson. And
you're welcome.
You will be listening from Jameson. He will probably write to you, or he will be CC'd in some communications. If you have, of course, you're more than welcome to come to our webinars. What I did, and thank you, Jameson, because you gave me time. What
Good.
I did is I finished. Yeah. I wanted to show you the tornado that I started to show. So here it is. What I did is I just run the same model. I run it again, right? And you see here that now you have a tornado that it's on a totally different level, right? Before we have the tornado at very detailed level, and now we have the tornado at this very high level, right? So that's exactly what I wanted to share, which is that you can have different levels of granularity for both the details and the tornadoes, right? And for also in this case, for all the results as well. So you can set up the results at any level. So what we will do, and thanks so much for coming, we will share with you this recording and we will upload it to our website. And you will be listening from us during this week. Thanks all. We didn't want to steal the whole hour, so we're going to return you 20 minutes. But this is what I wanted to share with you today. So it's introducing ModelRisk. And if you have people that it could be interested in that, please spread the word. This is our plan for taking over the US market now. And of course, this is, as Jameson said, this is a well-known product in Europe, and now we wanted to make it very well-known in both in the American and Latin American market.